Welcome back students. Today we are going to learn about a new chapter, physical and chemical changes. Students, it's there in your textbook at page number 90, chapter number 7, physical and chemical changes. Shall we start the topic? Yes. Students, we can see many changes in our surroundings. Daily we can see many changes around us. Is it not? Yes. So, there are certain changes where the original substance can be recovered. Okay. In some case, it cannot be recovered. So, if we are able to recover the original substance, the change is termed as reversible change. Clear? And if we cannot be recovered the original substance, that change is termed as irreversible change. Clear students? Yes. Now, let us learn about different types of changes. Yes children. Now, let us learn about mind map. Okay. So, here the chapter mainly deals with changes. So, changes, for example, crushing a can or cutting a paper. Okay. So, there are different types of changes like reversible changes, irreversible changes, physical changes and chemical changes. Okay. So, first about reversible changes. So, the changes in which the original substance can be recovered is termed as reversible changes. For example, melting of ice. Clear children? Yes. Now, about irreversible change, the changes in which the original substance cannot be recovered is said to be as irreversible changes. So, for example, burning of crackers. Clear? Yes. The third type, that is physical changes. Here, the changes in which the physical properties of the substance undergoes a change. Mean to say, size, shape, color will undergo change. So, for example, cutting a paper. Clear? Then, chemical changes. The changes in which chemical properties of a substance undergoes a change. So, the chemical properties of a substance undergoes a change, then it is termed as chemical changes. For example, burning of paper. Clear? Okay. Then, apart from all these different types of changes, we are also going to learn about characteristics of changes and some common changes. Clear? Yes. Yes children. Now, let us learn about physical changes. Okay. So, what do you mean by physical changes? Some changes involve change only in the physical property of that substance, such as shape, size, temperature and state. Okay. So, these changes are termed to be as physical changes. What are the changes? The changes will be there in shape, size, temperature and state. Okay. Then the change is termed as physical changes. Okay. Then in physical changes, there are no new substances formed. Here, no new substances formed. Then it does not alter the chemical properties of a substance. Only the physical property changes will be there. The chemical properties changes will not be there. Okay. So, here it does not alter the chemical properties of a substance. Clear? Then it can be either reversible or irreversible change. So, the change might be reversible or irreversible. So, for example, when salt is dissolved in water, the change is termed as reversible. Why? Because when we are allowing the water to be evaporated, then we can recover salt, is it not? So, this is one example for reversible change. Then next thing is about irreversible change. So, what do you mean by irreversible change? An example, if you are taking an apple and if it is cut into pieces, then no new substances form. We will be getting a small piece of apple, is it not? Then, but we cannot get whole apple back, is it not? Once we have cut into piece, then we will be getting small piece of apple, is it not? So, this is one example for irreversible change. Clear, students? Yes. Now, about chemical changes. So, what do you mean by chemical changes? Chemical changes is defined as the process in which the atoms of one or more substances are rearranged or combined to form a new substance. Clear? Yes. Here in chemical changes, chemical property of a substance changes. The chemical property of a substance changes. It's transformed into new substance. It's transformed into new substance with different chemical composition. Different chemical composition. Clear? In chemical changes, they are usually irreversible. Chemical changes are usually irreversible. Clear? So, for an example, baking a cake. Here, all ingredients are mixed. Okay, all the flour, all those ingredients are mixed, and then baking powder, the baking powder which is present in the ingredient, that will break down to form sodium carbonate, that is Na2CO3. Clear? And then bubbles of carbon dioxide is also there. So, here this is basically an irreversible change. Why? Because initially we were having flour and some more components, raw components. Then once it has been baked, now it is a cake, right? So, the change is irreversible, and then it is a chemical change. Why? Because the inner chemical composition has been changed. Clear? Yes. Now, another example, cooking of food. Here, the vegetables are initially we are just cutting, right? The cutting vegetables is termed as physical changes. Okay, and then cooking raw vegetables is termed as chemical changes. Okay, and then another example, a candle. When it is lighted, what will happen? Automatically it will melt. So, there is a change of state, that is the solid wax is getting melted to liquid, is it not? So, that change is termed as physical change. Clear? And then burning of wax. The burning of waxes will act as a fuel to burn. The wax will act as a fuel to burn, and that change is termed as chemical change. Clear? Yes, children. Now, let us learn about the differences between physical and chemical changes. So, first about physical change. Here it involves rearrangement of molecules such that internal composition of the substance remains same. Clear? But here in case of chemical change, a change in which new substance having different chemical composition is formed. Here a new substance with different chemical composition is formed. Clear? Then the second point is about here in case of physical change, only the physical property such as shape, size, color, etc. all these things, physical properties like shape, size and color will get change of the substance change. Okay. But in case of chemical change, only the chemical properties and composition of the substance change. Clear? Then the third point is about no new product is formed. No new product is formed. But here in case of chemical change, new product is formed. New product is formed. Then example for physical change, thawing of paper, freezing of water. Clear? And then here example for chemical change, burning of wood or paper and rusting of iron. Clear children? Yes. Now let us learn about characteristics of chemical reaction. Okay. So here a chemical change is also known as chemical reaction. Okay. So the substances involved in the reaction is termed as reactants, and the new substances formed during the reaction is termed as products. Clear? So change of color, we are going to learn about the change of color. Here the chemical changes which is indicated by a change in color, it is indicated by a change in color. Like for an example, cut surface of half eaten apple. The cut surface of half eaten apple will turn brown. Will turn brown. Why it is turning brown? Any guesses? Yes, because of the chemical reaction between air and chemicals which is present in the cut surface of the apple. Cut surface of the apple. Okay. Then formation of a precipitate. Now when sodium chloride is mixed with aqueous solution of silver nitrate, that is NaCl is mixed with AgNO3, then AgCl, that is silver nitrate and insoluble solid. Okay, we will be getting an insoluble solid, that is silver nitrate, which will be present as in the form of precipitate which will be there in the bottom layer. Okay. So here this is one example here. Okay. That is what. Next thing is about evolution of gas. In some changes, in some chemical changes, you will be getting the gas. Okay. Like baking soda. Baking soda, the respective formula for baking soda is NaHCO3. Then when this baking soda is mixed with lemon juice is nothing but citric acid. So when this baking soda is mixed with lemon juice, bubbles are formed due to the evolution of carbon dioxide. So this is one example. Okay. Next thing is about explosion of firecrackers. Here chemical changes produces light, sound and heat. Firecrackers, when we are burning the firecrackers, It will produce light, sound and heat. Clear children? Yes. Next thing is about characteristic smell. In some type of changes, it will generate characteristic smell. So, chemical change which gives distinctive smell. Some chemical changes will give distinctive smell. For example, spoiled food will give distinct odor. Curd smell is different from milk. That is different from milk. Clear? Now, let us learn about absorption and release of heat. Here, chemical reactions where heat is absorbed by the substance are known as endothermic reactions. Okay. For example, cake is baked. Is it not? When a cake is baked, heat is absorbed by the runny batter which changes to solid cake. So, heat is absorbed. So, this is basically one example for endothermic reactions. Clear? Next thing, when firecrackers are ignited, it will release the energy in the form of heat and light. Clear? So, such reactions in which heat is released, they are called exothermic reactions. So, this is what about endothermic and exothermic reactions. Yes children, now let us learn about some chemical changes. We would have noticed that a brownish red coating is formed on an iron object when it is left exposed to air and moisture. What is that brownish red coating? That's what said to be as rusting. Okay. So, I repeat children, a brownish red coating is formed on an iron object when left exposed to air and moisture. Okay. So, what is this? This flaky reddish brown layer is called rust. The reddish brown layer which is observed on iron is said to be as rust. Clear? Then the process is known as, so it is forming a brownish red coating, no, that process is said to be as rusting. That process is said to be as rusting. Clear? Iron reacts with oxygen and water. Iron reacts with oxygen. Oxygen is taken from air, okay, and water. We will add either tap water or distilled water. So, iron reacts with oxygen and water to form a new substance, that is iron oxide. So, here iron plus oxygen, iron said to be as Fe, oxygen is taken from air, that is O2, plus water either tap water and distilled water we can use. So, water, the molecular formula H2O. Okay. So, iron plus oxygen plus water gives rust. What is that? Iron oxide. Fe2O3 dot X H2O. Clear? Yes. After some time, the layer of rust falls off. So, after some time, the reddish brown layer will falls off, exposing the inner surface of iron, so that we can see the inner surface of iron. So, a new layer of rust develop. Clear? So, therefore, rust slowly eats away the metal. So, rusting, this process, it might lead to huge monetary losses. Okay. So, how to prevent this? How to avoid this? There are some steps. Okay. So, let us learn about that. Step 1, that is by avoiding the coming in contact with air and water. Okay, by avoiding the coming in contact with air and water. It can be done by coating the iron surface with oil or grease or paint. So it can be coated either with oil or grease or paint, so that the rusting will be prevented or avoided. Clear? Then the second step, second process is nothing but galvanization. Galvanization. So what do you mean by galvanization? Iron objects are coated with zinc. Iron objects are coated with zinc, and that process is said to be as galvanization. And by following this step also, we can prevent rusting. Clear? Then forming alloys of iron. Forming alloys of iron. By chemically combining it with other metals, either with other metals or else with other non-metals. That also prevents rusting. This step also prevents rusting. So this is what about rusting and how to prevent from rusting. Clear, children? Now let us learn about an activity about rusting. Okay, so here 3 test tubes are there. Okay, take 3 test tubes A, B and C. Okay, so in the first test tube, in all the test tube we are adding iron nails. Okay, 1 iron nail is added. Put 1 iron nails in each test tube. Clear? And then pour in the test tube A, pour some tap water. Pour some tap water. So already iron nail is there. Iron nail and tap water is there in the test tube A. Clear, children? Yes. Then in the test tube B, here we have already taken iron nails. So along with the iron nail, add pinch of calcium chloride. Add pinch of calcium chloride. So why we are adding here calcium chloride? So that it removes moisture from air. It removes moisture from air. So there is no water, only a pinch of calcium chloride along with iron nail is there in the second test tube. Clear? Then in the third test tube, here already we have taken iron nail. Along with that we are adding distilled water. Nail plus iron nail plus distilled water. Some amount of distilled water, and then add few drops of oil, vegetable oil. Clear? Why we are adding vegetable oil here? So that it prevents the mixture of air in water. Mixture of air in water. So that this test tube is free from oxygen. Can you understand? It cannot intake the oxygen from air. Why? Because oil is there. What oil will do? It will just prevent the mixture of air in water. Clear? So here in the test tube B, no water is there, and the test tube C, air, oxygen is not there. Is it not? Then what to do? Keep them undisturbed for 3 to 4 days. Keep them undisturbed for 3 to 4 days. Now let us observe the result. Okay, so here after 3 to 4 days, if you are seeing all the test tubes, test tube A, you can see the result that develops some rust. Okay, rust is observed in test tube A. And then the test tube B, where we have not added distilled water, it has oxygen. It has oxygen. Oxygen is there in the air. Is it not? It has oxygen but not water. But not water. So rust is not formed. Clear? Then in the test tube C, water is there. We have added distilled water but not oxygen. Oxygen cannot be absorbed from the air. Why? Because oil is there. Is it not? So here water is there but no oxygen. So out of 3 test tubes, rusting is observed only in the test tube A. Okay, so it proves that rusting require both water and oxygen. It require both water and oxygen. Clear, children? Yes. Yes, children. Now, the next topic is about browning of fruits and vegetables. Okay. So, you would have noticed in apple, potatoes, and so many fruits and vegetables and all, if it is kept open, if it is peeled off and kept open, then it turns brown in color. It turns brown in color. Once if it is peeled or cut open, it will turn into brown in color. So, why it is turning into brown in color? Any guesses? Yes, that is because of the oxidation reaction. Because of the oxidation reaction. Oxidation reaction is taking place on the surface of fruits or vegetables. So, once it is peeled or the surface is cut, then automatically after some time it is turned into brown, and that is because of the oxidation reaction. Okay, so here the skin of the fruit or vegetable, it acts as a barrier from surrounding air. So if it is along with the skin, then it won't get oxidized, it won't get brown color. Once if it is peeled or the skin is removed, then automatically if it is left open for some time, it turns brown, and that is because of the oxidation. Okay, so the skin of the fruit or vegetable act as a barrier. Then when the skin is peeled, the the cell wall gets ruptured. The cell wall gets ruptured, and an enzyme present in the cut surface of the fruits or vegetable, whatever the peel, we are removing the peel, no, the fruits or vegetable, in the cut surface an enzyme will be there. That enzyme will react with oxygen which is present in the air. Okay, so an enzyme in the cut surface will react with oxygen which is present in the air. Clear? So as a result, fruits or vegetables turn brown or dark in color. Brown or dark in color. So therefore, the changes in the, so automatically it will change the flavor and nutritional value. Once the color has been changed because of oxidation, automatically the flavor and nutritional value will also get changed. Okay, so here the oxidation decreases the nutritional value of fruits and vegetable. It decreases the nutritional value. So here the longer they are exposed to air, the lesser will be the vitamins. The lesser will be the vitamins. Children, I repeat once again, the longer they are exposed to air, the lesser will be the vitamins. Clear? Yes. Now, how to prevent this? How to prevent this? It can be avoided by brushing directly with lemon juice. It can be avoided by brushing directly with lemon juice. Why we are adding lemon juice? To prevent oxidative burning. To prevent the oxidative burning, we can add lime juice. If you are brushing the particular fruit or vegetable with the lime juice, it won't turn dark or brown in color. Okay. Then the second way, soaking fruits or vegetables in plain water. If it is peeled off, if it is already cut, the cut surface can be soaked in water, plain water, so that it slow down the oxidation process. It slow down the oxidation process. So it won't get tanned or dark brown in color. It will slow down the oxidation process. Clear? Then third step, it can also be done by cooking. If it is cooked, it won't change. Is it not? Then, or else by adding certain preservatives. By adding certain preservatives. So these are some steps which we can use to avoid this change in color, brown in color. Can you understand? Yes. Yes, children. Now let us learn about reaction between vinegar and baking soda. Okay. So they are common chemicals which are there at home, is it not? Vinegar and baking soda. So what is vinegar? Vinegar is nothing but 4 to 6% of solution of acetic acid. So basically it is an acid. Okay, and 4 to 6% means out of 100 ml it is 4 to 6% acetic acid. 4 to 6% of acetic acid is present in 100 ml of water. Clear? So here vinegar is basically an acid. Then next thing, baking soda. So what is baking soda? Sodium bicarbonate. Sodium bicarbonate. The molecular formula is NaHCO3. NaHCO3. Here this sodium bicarbonate is basically a base. Okay. So when this acid and base, these two substances react, what will happen? When these two substances react, brisk effervescence is observed, indicating the formation of new compound, and this reaction is basically irreversible reaction. Now children, let us learn about different types of chemical reaction. Okay, so first is about displacement. So what is this displacement? Here the more reactive metal displaces another less reactive metal from its solution. What do you mean by this more reactive metal and less reactive metal? Children, you can see here a test tube is there. Okay, so in the test tube we have taken copper sulfate solution. What is this copper sulfate? It is beautiful blue. Copper sulfate color is beautiful blue. Okay, so we have added copper sulfate to a solution, to water, distilled water, that is what? Copper sulfate solution, and here iron nail is there. So here this test tube has iron and copper sulfate solution. Okay, so if it is left undisturbed for some time, what will happen? Here this iron from the nail will displace the copper from copper sulfate, and iron will move to this place, that is iron sulfate. It will form iron sulfate and the blue solution will turn into green solution. Copper sulfate is blue, iron from the nail will go and react with copper, so it together it will displace the copper and it together form iron sulfate, which will turn into green solution. Along with that, you can also observe copper deposit, that is brown color. From the nail, this copper which has been displaced, that will be settled down at the bottom. That's what meant to be as copper deposit, which will be in brown color. Clear? So what is happening in total? Iron plus copper sulfate, copper sulfate solution is blue color, will react together to form iron sulfate, which is green in color. Along with that, copper deposits is also observed, which is brown in color. Okay, so now I am coming again. The more reactive metal, which one is more reactive metal here? The iron from the nail is more reactive metal, and the more reactive metal iron displaces less reactive metal copper. Is it not? The more reactive metal iron displaces the less reactive metal copper. Copper from where they are taking? Copper from copper sulfate. Okay, so that it together forms iron sulfate. Can you understand? So this is what displacement. Once again, the more reactive metal displaces another less reactive metal from its solution, and this process is said to be as displacement. Clear, children? Yes. The next step is about decomposition. This is also another chemical reaction, decomposition. So what do you mean by decomposition? It's nothing but a compound breaks down into two or more substances. A compound breaks down into two or more substances. So for example, when we heat calcium carbonate, it will break down into products like calcium oxide and carbon dioxide. Basically, this calcium carbonate is a solid, and when it is subjected to heat, it will break down into two products, that is calcium oxide, which is a solid, and carbon dioxide, which is a gas. Clear? So this is one chemical reaction. Reaction name is decomposition. Clear? Yes, children. Now the next chemical change is about combination. What is this combination? It's nothing but an ulta of decomposition. Here, two or more simple substances, that is reactants, combine to form a complex compound. Two or more simple substances combine to form a complex compound. That's what combination. Okay. So for example, formation of carbon dioxide. Formation of carbon dioxide. When carbon dioxide will form? When carbon burns in oxygen, it will form carbon dioxide. Clear? So this is what about combination. Next thing is about crystallization. Next thing is about crystallization. Okay. So what do you mean by crystallization? It is used to obtain pure crystals of a substance from its impure sample. Once again, it is used to obtain pure crystals of a substance from its impure sample. So what do you mean by crystal? What do you mean by crystal? It's the purest solid from substances. Purest solid from substances. Say for example, sugar, salt and alum are all crystals. Okay. So here basically this crystallization process is a physical change. It is a physical change. Why? Because there is no new substances is formed here. Okay. So since there is no new substances are formed, this process is basically a physical change. So that's what about crystallization. Now let us learn about saturation and supersaturation. Saturation and supersaturation. So what is this saturation, supersaturation? Yes. Let us learn. Take 50 ml of water in a separate glass. Okay, take 50 ml of water. Then to that water just add some 10 mg of salt in it. Dissolve the salt in it. Okay, so 50 ml of water with salt. Then continue adding some more salt in the water in the portion of 10 mg. Okay. Slowly add and stir it well. So when we are not able to dissolve any more salt in it, to some extent it will be having the potential to dissolve in it, then it reaches a state where it cannot dissolve the salt. Okay. So when we are not able to dissolve any more salt in it, then the salt, which is an excess amount to that solution, what it will do, more salt added settles at the bottom. It will settle at the bottom. Is it not? Yes. Now this state is said to be as saturated solution. This state is said to be as saturated solution. So what is saturated solution? It is a solution in which no more substance can be dissolved. No more substance can be dissolved. Clear? Then if the same solution is left undisturbed, if it is left undisturbed, automatically it will get dissolved. Listen, on cooling the solution, the salt remain dissolved for a while. After some time it might dissolve. then that state is said to be a supersaturated solution. Supersaturated solution. I mean to say here the solute is in excess amount, but still after some time, if it is left undisturbed, automatically it will get dissolved, and this state is said to be as supersaturated solution. Can you understand? That's what the solution is now called a supersaturated solution. A supersaturated solution contains more solute than in normal condition. Clear, children? Yes. So this is what about saturation and supersaturation. Yes, children. Now let us learn about the last part of the chapter, that is how is salt obtained from seawater. Do you have any idea? Yes. Now let us learn about that. Seawater is so salty, is it not? As you all know, seawater is so salty. Okay. So this salty water is used to obtain salts. It is used to obtain salts. Salt is obtained from seawater by which method? Evaporation. By evaporation. Now, seawater is collected in small ponds and left to evaporate. Okay, from the total amount, from the entire amount, they are collecting the seawater in small ponds, and then that is left to evaporate. After a while, all the water evaporates. Automatically, with the help of the sunlight, it gets evaporated. Okay, all the water evaporates, leaving a solid residue behind. The left out part is solid residue. What is that solid residue? Yes, this solid residue is the salt. So this is how they are obtaining salt from the seawater. Clear, children? Yes. Now, children, you can have a look at the candle. So, there is a candle where it has been already melted in a solid form. You can see that, is it not? In a solid form. Yes, this melting is nothing but the physical change. So, initial structure is getting varied here, the shape and size is varied, and this is the solid form of the wax. So once it is melted, it will form a size or structure like this, is it not? So this is one example for physical change. Now what I am going to do, I am going to just light up the candle. Yes, now you can see this burning of candle, is it not? So once if it is burned, what will happen? The wax is getting burned, and this is one example for chemical change. Yes, children, now you can have a look at the potato, okay, a full potato, and then here you can try this in your home. Take a small piece of potato, just peel it, remove the skin and cut the pieces of potato and leave it undisturbed for some time. Okay, so automatically after some time, if you are noticing that the cut potato will become tan color, okay, will become tan, light brown color. That is because of oxidation. What is this oxidation? That is, here the enzyme which is present in the cut surface, the enzyme which is there in the cut surface will react with oxygen which is there in the air. So that's what there is a color change. That's what there is a color change. It has been changed to light brown color. Okay, so this activity you can try it in your home, and just cut the potato, a small piece of potato, and handle it carefully. Okay, handle it carefully. Small piece of potato, and just keep it separately for some time. Observe the result, do this activity, and find that this oxidation has been happened, and send the result in email ID. Yes children, now we have come to an end of this chapter. So after watching the video, read thoroughly the chapter so that you can understand well. So thank you all. We'll meet in the next class. Thank you.